So now that we've done, this is the first part we did on the top part. Let's take a look at some core vocabulary. So a function describes relationships between quantities. It is a relationship where each input has exactly one single output. A domain, so if you remember domain has to do with our x values. So domain is a set of possible x coordinates for a function. It's a set of inputs for a function. Range is a set of possible y coordinates for a function. It's a set of outputs for a function. A parent function is the most basic function in a family. Functions in the same family are just transformations of their parent functions. So we're going to take a look at transformations, but let's first look at some parent functions. So constant is just in our book, it says that f of x equals 1. So anything that's different than that, that is a transformation. Now the graph, remember f of x is really just y equals 1. And so that's our horizontal line at y equals 1. Our domain, thinking about the domain is all of our x values. And so our domain in this case is all real numbers. So you can say all real numbers. You could also say, in interval notation, we can say it's negative infinity to infinity. The range in this case, the range is we only get y equals 1 in this case. So y equals 1. Now linear, that rule or equation is f of x equals x or y equals x here. And so just remembering the parent function of that. So think about graphing y equals x. The y-intercept is at 0 and the slope is 1 over 1, right? If there's nothing here, that's just 1. So up 1, right 1, up 1, right 1, or down 1, left 1, down 1, left 1. So this is the parent function of a parent graph of a linear function. And so the domain, so looking at this, so if you remember how to find domain and range, so we're looking at our x value, so we hit an arrow and then an arrow, right? It's going continually left. X is going negative all the way and positive on the right. So again, this is all real numbers, so we can say the same thing, all real numbers, or we can write negative infinity to infinity. Looking at our range or our y value, so looking at here, we notice that there's an arrow going down forever. So if you hit an arrow first, that means it's going to negative infinity, and then it goes to positive infinity. So our range in this case is also negative infinity to infinity. Now, another thing to think about when listing domain and range, it's always least to greatest. So the least, it's always going to be a negative infinity, and the greatest will be positive infinity. And these also could be numbers. So I know it's probably been a while since you've talked about functions and talking about domain and range. And so we'll talk about that throughout the year. Next, let's look at absolute value. So the absolute value of x. So if you think about it, if you plug in numbers here, if you plug in 0, you're going to get 0. If you plug in a positive 1 with the x, you're going to get positive 1. Now remember, what happens when you plug in a negative 1? Well, that's going to be a positive 1. So it flips, right? And if we put in a negative 2, it's going to be a positive 2. So this is why the graph of absolute value looks like this. So it's like a V shape here. So let's look at our domain. So it's going forever to the left. So it's going forever negative and forever to the right. So again, domain was we're looking at the x values. So in this case, this is negative infinity to positive infinity. Now let's look at our range. So the range, notice right here, there's no arrow. This is the lowest y value there is. And that is at a 0. And I'm going to put a bracket. Okay, bracket means you actually have a point here, and there is a point. So there is a difference between bracket versus parentheses. So if we had a parentheses of 0, that means you don't include that value. That means it's an open circle. In this case, if I plug in 0 into this function, I actually get a point 0, 0. So because the point is included, it is a bracket. Okay, so just kind of a reminder of how to write these in interval notation. Then next, we look at what's the highest the y values go. Now, you have an arrow, so therefore it goes towards infinity, so positive infinity, and it is a parenthesis. So notice these are all parentheses with infinity. There's no definitive number that it stops at. So therefore it is a parenthesis. Okay, so bracket means a number is included. Parentheses means it's not included. Parentheses are always used for infinity. And then open circles, if you have something like an open circle, that would be a parentheses. Again, something we'll go through even more throughout the year. Okay, quadratic. So this is our x squared. So there's a pattern to our x squareds. So y equals x squared. If we plug in a 0, that is 0. If you plug in a 1, that's a positive 1. If you plug in a 2, 2 squared is 4. So write 2 up 4. And then if you plug in a negative 1, so negative 1 squared, that's just a positive 1. And so notice that it's just going to go across. If you plug in negative 2, you get a positive 4, and then it makes this graph, a parabola. Now, just as a reminder, maybe in Algebra 1 or possibly in geometry, you talked about some patterns here. So with a parabola, if it's just the parent function, x squared, there's no stretching, there's no number in the front, there is a pattern, and it is always right 1, up 1, right 1, up 3. The next one will be right 1, up 5. So the parent function will go 1, 3, 5, and it's always right 1, and then up 1, right 1, up 3, right 1, up 5. Okay. Now let's look at the domain. Domain here, so it's very similar to our absolute value actually. So notice there's an arrow, so it's going forever to the left and forever to the right. So therefore this is negative infinity to infinity. In this case, we do have the lowest y value. Our lowest y value is 0. And so again, it's going to go 0 to infinity. So let's try that with this next example here. Identify the function family to which f belongs. Compare the graph of f to the parent function. And then, so a hint is graph the parent function on the right. So here, this graph here, if you look at what we've done already, which graph does this look like? Well, it's our absolute value here. So this is the parent function. So it always starts at 0, and then the slope, I'm going to call it slope, up 1, right 1, up 1, right 1, or up 1, left 1 of our absolute value. So let's graph that here first. Be careful with graphs because sometimes they're scaled. In this case, it is not scaled. So up 1, right 1. And then, so here is the parent function. I'm going to say this is, I'm going to call it h of x equals absolute value of x. So that's it in purple. So let's look at some things that happened here. And so first, this is our parent. So what happened to this blue graph here? So first, I hope you noticed that it moved up 1 unit. So that's one thing. And then let's look at the slope of the right side. It's up 1, right 1, up 1, right 1. Now what about here? This is up 1, 2, right 1, up 2, right 1. So it goes up much faster. So we can say that, I've had students say that it's, the slope is steeper on one side, things like that. Now I'm going to talk about the actual terminology. And this is going to be actually, it's narrower. So we can say that it's narrower. We can say that. But the technical term that I want you to get used to is that this is going to be a vertical stretch. So it gets narrower when it's a vertical stretch. Now, I can tell you, just by looking at the equation, and maybe you remember from doing the transformations activities in previous lessons, that this 2 in the front tells us it's a vertical stretch. This 1, adding 1 at the end, tells us it's moving up 1. So that kind of helps us out. I didn't talk about the parent function. I did say it in words, but it is an absolute value, and the parent function on that is this here. So I want you to try out this example. I'm working with just one type of function family here, so you can go and write it, write the words, write the equation, and then compare the graph. What do you think is happening to this graph as compared to the parent function? So draw the parent function and draw it here. All right, so trying this out. It's an absolute value again, and oh, I didn't write it here, so let's just say f of x equals absolute value of x. So just knowing the words and the parent function on that. We notice that number one, as compared to the parent function here, that it is flipped over, right? Maybe hopefully that's the first thing you notice, that it's flipped over, and specifically the x-axis. Now the terminology we want to use is that it's a reflection, or it's reflected over or across the x-axis. Okay, reflected over the x-axis. So that's the technical vocabulary word that we will be using this chapter and the rest of the year. The next thing I hope you notice is that it moved down 1, right? It's not at 0, 0, it moved down 1. And then it's a vertical stretch. It's definitely narrower than the parent function. And so it is vertically stretched. And we can say vertically stretched by a factor of 3. So vertical stretch by 3. You notice that by you go down 3, right 1. So just thinking about like the slope of that. And then again, we can take a look at the numbers in the front, or what the function looks like. Negative means that it's reflected. The 3 in the front means that it's a vertical stretch. And subtracting 1 at the back of the function, or just subtract it from the function, means that it's moving down that many units.